Hello, and welcome to the science of the brain. You see, this is me right here. Such a great likeness, isn't it? So, viewer voted topic for this particular week, and apologies for having it today as opposed to yesterday because I was a bit under the weather. So, every Saturday at 11 a.m. Central Standard Time, I will be live on Facebook talking about the viewer voted topic, and this week it's the brain, so woohoo! So let's get started, shall we? The brain. What is it? What is this crazy thing we have called the brain? Well, it controls our body. It processes our environment, so we're able to get stimuli from the environment, and our brain tells us what it is. We feel all the things with our brain. So we feel all the things. It stores memories, we learn, we remember, and it also fills in the blanks for us. So let's talk a bit about what makes up the brain. So we have neurons. These are our brain cells. Our neurons are our brain cells, which makes tissue. That's brain cells in lots of groups, which then gives us the brain, which is our thinker thingy. Okay, so neurons come together to make tissue, to make brain. Okay. I've got it kind of opposite, not mirrored, so that's why I'm a bit unusual. So here's a picture of a neuron. So this should say dendrites on the top. So essentially we have a neuron here. Hello, viewer, for hopping on. I'm just talking about the science of the brain today. So first we start out with neurons. These are our brain cells. And so we have a nucleus here, and that's like the control center of the cell. And then we have this long axon that's coated in what we call a myelin sheath. So our electrical signals transmit through here to get to the end, which is our axon terminal. So on the end here, we have that communicates with the next neuron cell. And so what happens is our neurotransmitters, and I'll talk about neurotransmitters here for just a second, release from here into the next brain cell. So neurons essentially, they talk to each other through compounds called neurotransmitters, and they do that through that axon on that myelin sheath. I have too many papers. So through that axon on that myelin sheath there, they transmit electrical signals to release neurotransmitters out of the end to go into the next neighboring cell that receives the information in these dendrites, okay? They're like the finger-like protrusions coming off of neurons. And neurons are very long. They're extremely long. They're some of the longest cells in the body because of these axons. So that's what neurotransmitters do. They help us feel the things, and then they are released from this little end here and picked up on the dendrites of the next neuron. Okay, so that myelin sheath that I talked about, that coating on the outside of that axon, that is like the rubber coating on your electrical wires in your brain and your nervous system. And so if you look at an electrical cord in your house, what exactly is the purpose of the outside coating? Kind of insulates it, right? It keeps it covered to where it can have a consistent current of electricity going through it, right? Well, the myelin sheath does that with neurons and with your nerves. So it coats and keeps that electrical signal from the neuron through the axon to the next particular nerve cell, or even, you know, the brain cells known as neurons. So what happens if that degrades? So if you were to cut through that electrical, you know, that rubber cord on the outside of your electrical cord, if you cut through that, what happens? You don't have a consistent signal, sparks are flying everywhere, and then you end up with a fire. So possibly a fire. But either way, you don't really want that to happen with your electrical cords. So what happens if this happens in people? We have multiple sclerosis. That's what this is. So what happens with these individuals is that myelin sheath is eaten through, and then they have those signals just kind of going off everywhere. That's why they're prone to twitching, jerky movements, and sometimes they have a hard time forming sentences. They can't talk so well because of the fact they're not able to get that signal to go all the way through. So, recapping really quickly, because we've had somebody who's just joined. We've been talking about what makes up the brain. Neurons form tissue, form the brain. This is what a neuron looks like. Some of the longest cells in the body. The outside coating of this is the myelin sheath, and when that degrades, because that keeps that electrical current flowing in between neuron to the next neuron, it releases neurotransmitters on the end here, and then the very next neuron on this end picks it up with these little finger-like projections called dendrites. They communicate through neurotransmitters, and when that outer coating on that long axon degrades, you get those random sparks of electrical signals, and that's what ends up giving you what we call multiple sclerosis. So that coating needs to be there just like the rubber coating on your electrical cords in order to have that conduction flow and insulate it and keep it where you want it to go. So now I want to talk about the parts of the brain. This isn't a real skull, it's plastic, but I like Halloween, so I have a lot of cool things like that. So we're going to talk about the individual parts of the brain. So we got the lobes. All right, so here we go. That's kind of hard to see, so I'm just going to point it out to you on my little visual aid here. So we've got our brain lobes. So firstly, right here, we've got what's called the frontal lobe. So this is the very, very, very front part of the frontal lobe. And what it does, it's our executive function. So it's in charge of our rationality, our reasoning, our problem solving, and our emotions. So that's what happens here. All right. Now here is our motor cortex. So if you got the moves like Jagger, it comes from this area right here. So this is in charge of movement. Then after that, you got your sensory cortex. So your sensory cortex is for all of your sensations. So feeling happy, you know, the pleasure centers of the brain happen right through here. Then you have your parietal lobe. Parietal lobe is part of our perception and kind of making sense of the environment and the world that we live in. Now, can we actually make sense of that? That's more of a philosophical question, isn't it? So philosophy there. So this is our parietal lobe here. So that's part of making sense of the world, arithmetic, spelling. And then we have our occipital lobe. This is where we see. Okay, so we have our eyes here, and they have like an optical cord that goes straight from the eyes all the way to the back. That's why when you get hit in the back of the head, you see stars. You remember I talked about that electrical signal along that axon? Well, goes both ways. You got electrical signal going from the eyes back to the brain, the part here on the occipital lobe. It can be reversed. So that's why you see stars sometimes when you get hit in the back of the head. So there's that. And then we got the very, very, very bottom is called the cerebellum. And the cerebellum is in charge of movement as well. And then you have your medulla oblongata would come through the bottom here. That's your brain stem. That's in charge of breathing, heart rate, blood pressure, those sorts of things. And then on the inside of your brain, you have your hypothalamus, your thalamus, and the things involved with your hormones. So that's where that comes from. So we've got, I haven't named him yet, or it could be her. We can make it a girl. I don't know. It's a skull, nonetheless. So those are the different parts of the lobes of the brain. So we're going to talk now about a very interesting case involving a brain injury and what it can do. Phineas Gage. All right, so in the 1800s, Phineas Gage was working on the railroad and trying to pound into a rail spike to get it to, you know, for the track. I don't do trains very well. I'm a scientist, but trains are not my thing. I could probably talk about combustion, I suppose, but still. Anyway, Phineas Gage. So he was pounding in a rail spike, and it got loose, and he hit it wrong, and it ended up right through his face. He lived, but he acted quite differently afterwards. So I have a picture of Phineas Gage. There he is, quite the gent. And what happened is, here's a scientific rendering. Ooh, I'm trying, of the rail spike going through here. And so that's essentially what happened. It went right through his face and then up through the top. So that was a heck of an ouch, wasn't it? So what happened? So we've got our rail spike coming up through here. Well, which part of the brain, since we just learned what the parts of the brain were as far as the lobes, does that affect? Well, it went through his face, you know, and it came out the other end, wait, on this side. So it cut off the frontal lobe, which is our reasoning and our rationale and being able to problem solve in our emotions. So a lot of the townspeople, after this happened, he wasn't quite the same. A lot of people thought he was drunk. They said that he acted drunk all the time. Well, lost his ability to have rationality as well as, you know, problem-solving skills and all the things that are associated with the frontal brain. So that would be Phineas Gage. Another interesting case, Abraham Lincoln. All right, so Abraham Lincoln, we know, unfortunately was shot in the back of the head, but he lived for hours afterwards due to the medulla oblongata keeping his breathing, heart rate, and blood pressure alive, keeping it regulated and keeping him alive. So when you think about Abraham Lincoln, all right, so he's sitting along, he gets hit, you know, with a bullet in the back of the head. Well, his brain stem was still intact, and his brain stem was not harmed with that particular injury, so he was still able to breathe. He was probably very much brain dead, but his medulla oblongata kept him alive for a few hours. Now, the kind of gross aspect of this, though, since the scientists at the time had not developed germ theory, they were going in to the back of his brain and just kind of prodding around a little bit, looking with pencils and stuff, just like, ooh, wow, we can see in his head. It's just kind of morose and a bit strange and morbid, but that's exactly what they did. And they're like, how is he still alive? Well, the medulla oblongata, actually. So we think about that now, and we're kind of like grossed out at the thought. Can't imagine if they had smartphones back then, how weird that would be. Abraham Lincoln and all that. Anyway, so that's essentially what they did. And so that's how Abraham Lincoln was not allowed, but able to live for several hours after such an injury like that. So he had his heart rate and blood pressure and everything still going. So now let's talk about other things involving the brain. Patterns in light. This came up on as a question to me last week or last week or the week before about patterns in lights and what exactly happens when they induce migraines and epilepsy. Well, this triggers electrical pulses in the brain. So certain patterns in lights with people who are hypersensitive to these types of patterns or these light type, like strobe lights or even a lot of light at once, can actually fire off certain neurons in a specific pattern in the brain that causes heavy electrical pulses. And these electrical pulses actually can seize a person, hence the seizure, to where they're unable to control their body. So people who are sensitive to this, there's still a lot of research that's going on, and still we don't know a whole lot of things in regards to this, but we know that some individuals with certain patterns presented to them, it fires off their brain neurons in such a way to where there's just too much activity and it's overwhelming. That would be my answer for that. So let's talk about the cool things that the brain can do. The law of closure, all right? So the brain fills in missing information, lines and that sort of thing, in order to complete a picture or even, you know, correct some sentences. So for the first example I have here, there is no square here, but we see a square because our brain is filling in these lines, in these patterns, because it's so used to seeing this type of image. that our brain does it automatically. So even though we got 4 little Pac-Man dudes here in such a way, we've got our square here. That makes less. Oh, okay. We have a new person on here. Hey, Carl. And hey, Jeff. So this is called the law of closure. So this is what our brain does, involving filling in the gaps. Another thing that's pretty interesting. Oh, it makes image processing on a computer really hard. I see. Yes. So for this particular one, according to research at Cambridge University, it doesn't matter in what order the letters in a word are. So essentially I can read this and I know what it's trying to say because my brain is able to sort out what it is that what it meant to say. And this comes again with that law of closure, that being able to recognize patterns and that sort of thing, things that our brain is used to. The human mind does not read every letter by itself, but the word as a whole. So it's not just, phonics. It's a bit more than that. So, all right, so now I want to talk about the 10% myth. This is bunk, it's bollocks, it's absolutely not true. You use more than 10% of your brain. We use our whole brain. There's no 10% part, and there's none of that. But MRIs show us this. So we can see through MRI scanning, that's magnetic resonance imaging. So anytime somebody suffers a brain injury, they can go in and have that type of scan, and they can see which parts of the brain are firing off and are active at the time. They've done studies involving individuals who have psychopathic tendencies versus like people who aren't clinical psychopaths, and they can see different parts of the brain fire off with certain types of images even. So we know we use our entire whole brain. And even in regards to head injuries that I've discussed before, there have been some cases where people might suffer a bit of brain damage here. Other parts of their brain can take on the job that part used to have. So there have been some cases on that. Now it's not all too common. It's quite difficult, but it's still worth noting that our brain is still the least understood organ of the whole body, but it does things that we don't quite comprehend just yet. Not fully. Let's talk about brain tech. Okay, so we've already shown that we can transmit thought through the internet to another person. And there are some current recent tech, and especially with Elon Musk, he wants to be able to have our brains wired to our devices to be able to make that type of connection. And there are some research groups that are trying to download thought into a computer. So that'd be quite handy, especially, if you want to save some memories, but, you're not so good at remembering stuff sometimes. But, then with the whole attaching your smart device to your brain, just because you can, does that mean you should? Can you imagine being attached to your phone all the time? I don't know that I would want that, but, still. That would be kind of problematic. I don't know. Hopefully there would be like a night mode or something. Like, I'm asleep now. Shut up, phone. My brain is busy as it is. So, that's all cool. Now, magnetism. Our brain is susceptible to magnetism. Magnets can alter the mood. Now, we're talking about strong magnets. We're not talking about light household magnets. It has to be relatively strong, at least 2 or 3 Tesla. Now, an MRI can alter mood of individuals who suffer depression or bipolar disorder, and those are about 8 Tesla. So that's the strength of a magnet. A household magnet, I believe, my understanding, is a little bit less than 1. So if you figure a magnet much stronger than that, that's the kind of magnet that you'd be looking at if you want to do some serious mood alteration. Now there's something called the Korean helmet that somebody has made that has super strong magnets in it that help induce people into a euphoric type of state to where they can actually have hallucinations a little bit, and it alters their mind, their mood a bit. So we are susceptible to this type of magnetism. Now, we are susceptible also to different types of electromagnetic radiation, especially in regards to sunlight. So our sun helps reset a lot of what we call circadian rhythms in our body. So that type of electromagnetic radiation is actually quite essential for our daily operations. So a lot of doctors will recommend, especially if you have light insomnia, as soon as you wake up in the morning, go stand out in the sun for 5 minutes to kind of reset your body and allow you an opportunity to kind of kick off those circadian rhythms that associate us with our sleep patterns. Now, some people actually suffer depression in the wintertime because the sun isn't out so much, and so they'll have sun lamps sitting by their bed. So we know we can change the biochemistry of our bodies just from certain levels of electromagnetic radiation, which can in turn be positive and help us overcome, depressed states and that sort of thing. Now, this is where I talk a little bit about depression. Okay, so depression and also others who suffer like bipolar disorders and that sort of thing, there is no just getting over it. So a lot of people are like, oh, you're just depressed, you're sad today. And they toss that word around a lot, but clinical depression is far more serious than that. This involves those neurotransmitters not functioning correctly in between neurons, so a person just can't get over it. And it's not just in their brain, it is body-wide. So somebody who suffers clinical depression is going to feel it all over, not just in their brain. They suffer body pain, unexplained pain. They're cold in parts of their body. Even on some really low, severe days where they have the black dog, as they call it, following them, they can barely form sentences. So there are some people who suffer depression on such a level to where there just is no getting over it, and just getting out of the bed and showering could take hours because they're in so much pain. They can't think properly. They can't formulate sentences. It is a true illness. So when your brain is altered in that kind of way, it affects you holistically. So your brain is extremely important. So let's go over a little bit of a summary here. So don't tell depressed people to get over depression. That's just what I'm trying to say there. So the summary: the brain, magnets do cool stuff to it, can alter your mood. It's extremely complex. It's hella complex, and it's the least understood organ in the body. It controls just about everything in your body, and it is just the maze ball. Your brain is really cool. It does lots of cool stuff for you. And if something goes awry, it can affect your whole body. So that's why it's very important to be kind to you, be kind to others, and everybody only has one brain. So it's important that we kind of keep that in mind. Perception is a bit of, how we see the world is quite important, but a lot of that comes from what our brain does. So be kind to others. You don't know what they're battling. So I hope you guys enjoyed that. That's the science of the brain. Rawr. I don't know what to name my skull here. So if you guys have questions, you can ask me here. I will post this particular video on YouTube as well, and it will stay on my Facebook channel, so you can come back and look at it anytime you want. And then next week, I don't know what the topic is next week. I'm going to put a poll up on Twitter, and that's usually where I go when people get to vote. This particular topic was voted for, and it last week. And so I think the next poll will be going up today, so everybody can vote on which topic they want to hear about for the next show. So I hope you enjoyed that. You can find me on Twitter. You can ask me questions here on Facebook. And I also have a YouTube channel where I put these videos over there as well. So you have lots of ways to kind of interact. But thanks for watching. I hope you guys have a good day. Sign off. Bye.